And today I want to show you it's not complicated, it's not scary, and you can do it. A Watts link has three main components. Link bars, each mounted to opposite sides of the vehicle frame. The other ends of those link bars connect to a third link that's mounted vertically to the center of a solid axle. From our rear axle, we need to secure the axle to the frame in a way that still allows up and down movement. A panhard bar, which you're likely familiar with, does exactly that. The panhard bar actually pushes the chassis to the side as the bar follows an arc. But the rotating propeller absorbs those arcs, causing the center point, which is attached to the axle, to move in a more vertical motion. But how does this floppy contraption act? With the panhard bar removed, notice how the distance between this point on the axle and this point on the chassis changes. Installing a bar between those 2 points prevents this change. Even if we shorten the panhard bar and mount it to the center of the axle, we see the same result. But if we disconnect the panhard bar from the axle and instead connect it to a propeller, the sideways motion comes back. This is because when the chassis pushes the bar left, rather than pushing the axle with it, the propeller just rotates clockwise. We can see that the rotation of the propeller causes the bars to move in opposite directions. When the right bar moves to the right, the propeller pushes the left bar left. And when the right bar moves left, the left bar right. Wow, notice how the left bar is moving in the opposite direction of the chassis. So let's prevent that movement by connecting the two, and bam! Suddenly this floppy contraption is keeping the axle firmly in place while still allowing up and down movement. All the forces in the bars and the propeller remain the same, we just can't see them anymore. Because